gravitational waves, comets careening through space, and the fate of the mighty star Betelgeuse. These topics spark curiosity and awe, revealing the intricate tapestry of our cosmos and our place within it. Let's unravel these cosmic mysteries, integrating the most recent discoveries and insights from astronomy so that we can better appreciate both the grandeur and the subtlety of the universe that surrounds us. We begin with gravitational waves, one of the most profound revelations of modern astrophysics. Gravitational waves are ripples in the very fabric of spacetime, set in motion by cataclysmic events, colliding black holes, merging neutron stars, or the explosive deaths of massive stars. Detected for the first time in 2015, these waves have opened a new window into the universe, allowing us to observe phenomena that were once entirely invisible. The question arises, can we deflect, redirect, or shield ourselves from these cosmic waves? It's a tantalizing idea, conjuring images of advanced technology or protective barriers. Yet reality is far more subtle. Gravitational waves interact with matter so faintly that they pass through entire planets, stars, and even galaxies with barely a whisper. Their influence on Earth, despite originating from events billions of light years away, is measured in fractions smaller than the diameter of a proton. Even our most sensitive detectors, like LIGO and Virgo, strain to register these minuscule distortions as they pass through. Recent scientific consensus is clear. Deflecting gravitational waves is beyond the reach not only of current technology, but of any technology we can presently conceive. Unlike electromagnetic waves, which can be blocked or redirected by physical barriers, gravitational waves simply do not interact with matter in a way that allows for manipulation. Their subtlety is both a challenge and a gift, granting us the ability to observe distant cosmic events without interference, but also leaving us essentially powerless to control or shield against them. For now, and likely for the foreseeable future, gravitational waves will remain an untamed messenger from the cosmos, whispering secrets rather than threatening harm. Turning our gaze from these intangible ripples to something much more concrete, we confront the threat posed by comets. Comets are primordial wanderers, composed mostly of ice, dust, and rocky material, tracing long elliptical orbits that can bring them close to the inner solar system. When a comet approaches the sun, its surface vaporizes, creating a spectacular tail that can stretch for millions of kilometers. But while their beauty captivates us, comets also pose a potential risk. A comet on a collision course with Earth would be a rare but significant event. The devastation wrought by such an impact would depend on the comet's size, speed, and composition. Large comets, tens of kilometers across, could unleash regional or even global destruction, triggering tsunamis, wildfires, and atmospheric changes that could alter the climate for years. Even smaller comets would cause catastrophic damage if they struck a populated area. The famous Tunguska event in 1908, likely caused by a small comet or asteroid, flattened thousands of square kilometers of Siberian forest. Despite the potential for destruction, the odds of a comet striking Earth are extremely low. The solar system is vast, and the number of comets that cross Earth's path is minuscule compared to the emptiness of space. Nevertheless, planetary defense is a priority for astronomers and space agencies. Modern telescopes and survey missions, such as the Near-Earth Object Observations Program, vigilantly scan the skies for any object that could pose a threat. The catalog of known near-Earth objects grows every year, and while asteroids are more common culprits, comets are also tracked closely. Should a dangerous object be detected, various mitigation strategies, ranging from kinetic impactors to gravitational tractors, are under study, aiming to nudge the object away from a collision course. In recent years, public awareness of these threats has grown, fueled by dramatic depictions in media and the occasional surprise visitor from the Oort cloud. Yet, current assessments remain reassuring. The probability of a catastrophic comet impact in any given year is exceedingly small. Still, vigilance is essential, and the continued improvement of our detection and response capabilities ensures that humanity is better prepared than ever before to face these rare celestial dangers. Now, we journey to one of the most iconic stars in the night sky, Betelgeuse. Situated in the shoulder of Orion, Betelgeuse is a red supergiant nearing the end of its life. Its immense size, hundreds of times larger than the Sun, means that it will one day explode in a supernova, an event that will outshine every star in its constellation and be visible even during the day. Betelgeuse has captivated astronomers and stargazers alike, especially in recent years when the star began to dim unexpectedly. In late 2019 and early 2020, Betelgeuse's brightness dropped to levels never before recorded, prompting speculation that its supernova might be imminent. Observatories around the world trained their instruments on the star, searching for clues to its fate. But recent research has clarified the situation. The dimming was not a precursor to explosion, but rather a manifestation of Betelgeuse's variable nature and the complexity of its outer layers. Astronomers now believe that the dimming was caused by a combination of factors: large convective cells on the star's surface, and the ejection of dust that temporarily obscured its light from Earth. The star has since returned to its usual brightness, and careful study has revealed no signs that the supernova is imminent. The latest estimates suggest Betelgeuse will not explode for another 100,000 years. While this cosmic timescale is fleeting for a star, it is comfortably distant from human lifetimes. When the supernova does occur, it will be a spectacular sight, but it will not pose any threat to Earth. Betelgeuse is located about 640 light-years away, far enough that its explosion will be a show, not a danger. Adding intrigue, a recent burst of gravitational waves was detected near the location of Betelgeuse. However, astronomers have found no direct connection between the star and this event. Gravitational waves can originate from many sources, and in this case, the burst is likely unrelated to Betelgeuse itself. The star continues its slow, majestic evolution, providing astronomers with a living laboratory to study the final stages of stellar life. In summary, the universe is a place of both immense power and delicate subtlety. Gravitational waves sweep across the cosmos, offering insight but requiring no defense. Comets, while potentially destructive, are rare visitors, and our vigilance grows ever sharper. And Betelgeuse, while destined for a dramatic finale, reminds us that in astronomy, patience is often rewarded with deeper understanding rather than sudden spectacle. As we ponder these cosmic questions, we are reminded of the ever-evolving nature of scientific knowledge. Each discovery adds a new thread to the tapestry, connecting us to the universe in ways both profound and practical. Whether we gaze at distant stars, monitor the skies for wandering comets, or listen for the faint echoes of gravitational waves, we are participants in a grand adventure, one that binds curiosity, caution, and wonder in equal measure.